All right, section 16, finding, increasing, and decreasing with derivatives. This is a pretty cool section because this is where we can start seeing the things that we're learning in calculus kind of come to fruition. So the first derivative process is one of the things in this section. So this process is something where we use whether or not something's increasing or decreasing for useful purposes. First thing, take the derivative. Second thing, find the critical points. So it's kind of like section 14 all over again, just finding critical points. But now we're doing more with them. Now we have to test the values in between all of the critical points to see if the function is increasing or decreasing on either side of our critical point. If we tested our critical points, we'd find that their derivative is either 0 or undefined because that's like the definition of a critical point. So we're testing values on either side because that's where things will actually be increasing or decreasing. And if it's increasing to decreasing, it's a maximum. If it's decreasing to increasing, it's a minimum. Now this is not something you need to memorize. In fact, I'm going to do this hand thing in class, and so you'll probably see that. But also you can just do increasing arrow up, decreasing arrow down. Look, it looks like a maximum. If we followed that, we'd be making a maximum. Decreasing to increasing, down to up. Hey, look, it looks like a minimum. So it kind of makes sense. Now, there are three types of questions I'm going to ask in the section. One of them is this first derivative process, where you actually have to use the first derivative test to find maxima and minima. Another one is you just need to find the intervals on which the function is increasing or decreasing. It's another one where you're going to have to test values in between our critical points and figure out the different intervals at which we're when we're increasing, when we're decreasing, that sort of thing. All right, the last thing is using a position function to determine whether a thing is speeding up or slowing down. So it's the same idea. If we're going to have to take another derivative and see if that thing's going up or down. This is all just testing to see if things are increasing to decreasing or decreasing and increasing, that sort of thing. So let's get to problems right now. I'm going to zoom in. All right, our derivative, that is the first step, is 3x squared minus 3x minus 6. Easy step here. Factor out a 3. It's pretty obvious that there's a 3 in all these. I'm just going to set it equal to 0 because I can tell from this that nothing is going to make that undefined, so I can just look for where the critical point is 0. So let's see, 3 times x squared minus x minus 2. This is another easy factor. It's going to be x minus 2 and x plus 1. And so we have our critical points. They are x equals 2 and x equals negative 1. Now I have to do a test to figure out where this thing's increasing or decreasing. I know it's 0 at these points, so I got to test values on either side. So I'm going to put negative 1 up here and 2 here, and I'm going to test negative 2. I'm going to test 0, and I'm going to test 3. Now I'm testing these in the derivative, so I'm going to test them in this. If I plug negative 2 in this, I get negative 1, negative 4. That's positive 4 times 3 is 12, so I get 12. If I plug in a 0, I get 0, 0, negative 6. If I plug in a 3, I get 3 times 1 times 4, which is 12. So it's going, okay, these numbers are the slopes at those points. So I can tell it's going from increasing to decreasing and then back to increasing. So at negative 1, x equals negative 1. At that point, it switches from increasing to decreasing. So the way I'm going to write this is I'm going to write increasing is happening from negative infinity, so where this function starts, to where does it end? Negative 1. It also increases over here on this side, so from 2 to infinity. All right, decreasing. Well, that happens in between these 2 points, so from negative 1 to 2. Notice how I used open parentheses, whereas closed parentheses include the interval, open parentheses don't, or the endpoints of the interval. It's because the slope is 0 at these 2 points. It's not neither increasing nor decreasing. So this is it. Increasing, decreasing, I got it. So we basically did the whole first derivative test. We just didn't figure out maximums and minimums. We could have very easily. The maximum happens at negative 1, the minimum happens at 2. But we're just writing the interval because that's, or where this thing's increasing or decreasing, because that's what it's asking for. Next one, we're actually using the first derivative test. So this is a different function. I have to figure out its derivative, 3x squared plus 6x minus 24. Again, I can factor out a 3. Funny trend. Now I want where this thing's equal to 0, so I'm going to plug in a 0 here. And I got a factor now, x squared plus 2x minus 8. It's a pretty easy factor. I get x plus 4, x minus 2. All right, x equals negative 4 and x equals 2 are the points those are my critical points. This derivative was not undefined anywhere. I didn't need to worry about any of that. So I just need the test on either side of these. So negative 4 and 2, a value in between is 0. Just a hint, 0 is usually like a really easy point to test. 3 is a value above, and negative 5 is a value below. All right, and this is like cut off from this problem. If I plug in negative 5, I'm going to get 3 times a negative value times a negative value. I'm definitely going to get a positive value. Unlike over here, I didn't need to find these values. I just needed to know whether or not they were positive or negative. If it's positive, that means this is increasing. All right, 0. I plug it in, I get negative 24. That's a negative number, so this is decreasing. 3, if I plug into my derivative, I get positive here, positive there. We're back to positive, we're increasing. So this thing actually has both of them being minima or maxima. And x is equal to negative 4 is our max, and x is equal to 2 is our min. Now this says find the maxima and minima, not the x values of the maxima and minima. So I should actually find these points. Let's throw them in extra space. I kind of zoom these out so they're smaller, so it's harder for me to fit things in the space. So our max is actually at negative 4, comma, and this is a totally legit way to write this on the test. Negative 4 cubed plus 3 times negative 4 squared minus 24 times negative 4 plus 13. There we go. That's the point at which there's a maximum. And our minimum, this happens at 2, comma, and now I can just plug all this stuff in the original function, 2 back into all this stuff up here. So 2 cubed, oh, I know that's 8, plus 12, minus 48, plus 13. And I don't need to simplify this. I'm not looking for you to simplify this. I'm just looking for you to give me 2 points. So a quick recap of this problem. I took a derivative. I factored the derivative, found the critical points. I tested the critical points by looking at values on either side of them. I found that it was increasing, then decreasing, then increasing. I knew negative 4 was a max because increasing to decreasing gives you a max. I knew 2 was a minimum because decreasing to increasing gives you a minimum. And then I plugged those numbers back into my original equation to actually find the points at which the minimum or maximum occurs. And that was this nastiness. You could have actually figured this out. It's not actually that bad of math, but it takes a while. This is a completely legit way to leave answers on your quiz. And I hope this helps you with the first derivative test and finding increasing and decreasing.